Hello, so we have today a new phone, an iPhone 16 Pro Max that came in for a charging issue. The phone came from, as you can see it looks really good. It has no scratches, no dents, it doesn't seem to be fallen. It came from another repair shop. The owner said that they have charged the phone with a non-standard charger. I don't know what that means. And the repair shop tried to replace the charging connector, and it didn't fix the issue. Now the phone doesn't start at all, so what I can do is I can connect the USB, and let me put it on the screen so you can see the USB supply right here. Good. So I'm gonna connect it to the phone, and we can see 42 milliamps drawn, current draw here, and that's it. It doesn't do anything else. It doesn't go up or down, it just stays at 42. So that's interesting. Now the 16 series, the charging circuit is quite similar to the 15 series, so it's kind of the same principle since they came with the USB-C connector. So I have here a sketch made by me for the charging circuit in iPhone 15 Pro Max, but it applies to all 15 models, and it applies to the 16 models too. So what we have here is the charging IC. This is the main power supply IC that creates the VDD main. We have the wireless charger controller, the USB controller that is paired with ROM, read-only memory flash here. And also you can see in this schematic the CPU and the PMU. This is the battery connector, and this is the USB-C connector, the dock. Okay, so what happens when we plug in the USB-C connector? We get the 5 volts that you can also see here, right? Because it didn't negotiate anything. It goes through this PPV bus E85, and it goes to the charging IC, then it powers on the USB controller too. And the USB controller is speaking with the charger, and if the USB controller considers that it has a good and proper charger connected, then it will issue a signal here on this line that is called ACE2 charger VBus valid, right? It's gonna just send a short blimp like you see in this oscilloscope capture here. It sends a 3v3 signal, like a short one, and then the charging IC speaks with the battery. It speaks with the battery using the I2C protocol, so it's using the SDA and the SCL lines. And it looks at the battery, sees what model it is, how charged it is, and then it considers if it should deliver the power to charge the battery or not, right? The battery is connected, the data line is connected to the charging IC, the clock line goes through the PMIC, this is the main PMIC, and also the charging IC is speaking directly with the CPU via these I2C2, SMC, SCL and SDA lines, also in the I2C protocol. Good, so that's kind of it. This is the basic principle that it uses. Now the problem we have here is that on the 16 Pro Max, all the chips, so USB controller, charging IC and the power main supply are on the same part of the board. So if we look here, they are under this big shield. So there's a big shield, hefty one here where the NAND is, and here we have the USB IC, the charging IC and the main supply IC, right? The problem is that if we need to replace, as I said, the USB controller because we believe it's faulty, then we'll have to split the boards, because we also need to replace the ROM chip that is on this side, so it's basically under this this connector here. So then it's gonna be a lengthier process. It's gonna cost the client, the customer, more money, and yeah, that's gonna be the expensive solution. If the problem is related to the charging IC, then it's gonna be simple. We just cut the shield and replace the charging IC. So yeah, that is it. I'm gonna open this phone and we're gonna do some measurements to establish which one is the cause of it, because I don't want to split the boards and lose time and lose the customer's money. So we're gonna have a look at the phone. First of all, I'm interested in seeing if there is any communication with the battery. We can use the oscilloscope for that. I'm interested to see if the USB controller sends this charger valid message, but I'm also a bit concerned of this behavior with the 42 milliamps, so I'm interested if we can power on the phone using the power supply and see if it starts. And also if it starts, then I'm curious if we can see it on the USB on the computer, because if we cannot see it, then the USB controller will definitely need to be changed. Hopefully it's not, because it's gonna be the expensive way, but we'll see how it goes, and I'm gonna come back once I have the phone opened and prepared. Hello, so I came back with the phone opened, so I just removed the back, I removed the covers, and I've disconnected the battery. The screen is still in place because I'm curious what it does when connected to power. So I'm gonna connect it to the power source. So we'll use this supply that you see here, the PSU one. Let's find the cable for the 16 Pro. This is the one, and I'm gonna connect the power supply, replacing the battery. Good. The phone is connected to the power supply, and I'm gonna power on the supply in 3, 2, 1, and supply is powered on, and we can see a power consumption of 24 milliamps. Now that is not a good sign. That one should be 0 always, so we should have no power consumption at all when powering through the battery. This is really weird. I'm gonna try to power it on using the button in 3, 2, 1. Yeah, so the phone powers on now, and it looks like a relatively good power behavior. We can see the graph here. It doesn't look bad at all. We have the Apple logo. Hopefully we have nothing on the screen, but we'll see if there is any kind of and there is 2 people here. I'm gonna have to blur the image. Unfortunately, I don't have the code for the phone. I've asked for it, I didn't get it yet. What I'm curious is what happens if I connect it to the computer now. So I'm connecting it. Yeah, and it did beep, and it says accessory connected, unlock the iPhone to utilize the accessories. So it might be that the USB controller is actually good in working condition, because obviously there is some kind of a communication with the computer. So now there is actually not much I can do further. I will have to remove the display, remove the board from the phone, and then we can go under the microscope and continue our investigation and see what we can find, and what could be the thing that consumes 25 milliamps. Yeah, I'm gonna turn off the supply now, and I'm gonna come back when we have everything opened. Okay, so we're back with the board under the microscope. We have everything disconnected, so is the board alone. I think the first step would be to actually measure this battery connector, right? Because I said I was interested in the clock and data lines. But if we're still here, we're gonna measure everything. So we have the multimeter, you can see it up on the screen where it says multimeter. I'm gonna put the red probe on ground, and on the positive probe, let me set up so you can also see, yeah, the board view. So this one we have 0.397 and we should have like 0.418, so we're pretty close. This one is the analog voltage 0.52, we have 0.52. This is open line, and now it's the clock line, this one 0.565 and it's 0.587, and the other one, the data, is 0.5432, and this one is 0.438. The connector looks fine. Now what I like about this iPhone 16 Pro and Pro Max boards is that it has a lot of very useful test pads here and here. The clock and data lines are here, the charger valid is here, and here on the other side we have here the VDD main, these two. So what I'm interested in, as you saw, we had that power consumption of 25 milliamps, and that was weird. Now I'm interested in where that consumption takes place. Does it take place on the battery side or on the VDD main side, right? So what I'm gonna do is I'm gonna connect, so I have the clips here from the power supply. I'm gonna connect the negative to the board. I'm gonna use this crocodile clip and connect it here to this side where we have a ground, right? It's like that. And on the other one, I'm gonna just connect it. I'm gonna connect it to my tweezers, and I'm gonna touch this VDD main line, right? So I'm powering on the supply. You can see it's 4.1 volt, right? And now I'm gonna come here on the main point, right? And I have zero power consumption. So zero power consumption means that our issue is not on the main PMIC and on the main supplies of the phone. So the problem lies somewhere here on one of our chips, because as I showed you here, this is where we put initially the supply instead of the battery. So it's right. So this is the schematic, right? So this is when we put the power supply on instead of the battery, and we had a 25 milliamps. We are pushing voltage here. It was powering on this chip, and this chip, and this one was creating the VDD main, because we saw that the phone was properly booting. So we had main, right? And I was interested if our 25 milliamps are being consumed here on this side or on the other side, away from the main supply and through the rest of the phone, because that main line, so if we look here, right, we have here the battery. So the battery comes here in this chip, which is the main supply chip, and this is producing the VDD main, which is going through all the chips almost everywhere on the phone. Is going to the PMIC, to the camera controllers, to everything. So now at least we figured out that we have a problem somewhere in the charging circuit here, and here something is consuming the 25 milliamps. So what's left to do now is to actually cut this shield. So our chips are right here. This is the NAND, right? And our chips are right here. Here is the USB controller, here is the charging IC, and here is the main supply chip. So I'm gonna cut the shield like here all around, and I'm gonna protect with some tape here around this, and we'll see when we get there what our problem could be. Okay, so I have the board here, it's opened. We have a good view of the chips. I've connected the power supply. See if I turn the power supply on. Sorry, let me take you to the microscope. Right, so if I turn the power supply on, we can see we're going to 23 milliamps. Good. Now, it makes no sense to measure with the oscilloscope the lines for the clock and data. We're gonna have clock because that comes from the PMIC, but on the 16 Pro models, the data line will not go up unless we have the battery connected, and I don't have a battery and I don't want to remove the battery from the phone. Right, so I think the sensitive thing, now that we have the shield removed, we can take the thermal camera. I have here the Infiray P2 Pro, and we're gonna connect it to the computer, and we're gonna watch what happens when we power on the phone with the camera. Let me switch you to the camera view. Okay, so camera is connected. We see here how it looks like. I'm gonna power on the supply in 3, 2, 1. Yeah, and we see the chip in the middle, which is the charging IC, glowing in one corner, right? We can clearly see that. One corner glows. Good. So it's clear that we have a problem with that IC in particular. Let me have a look here and see what happens in the corner, in that corner. So if you look here, we have a ground here, ground, so all these are grounds, so we have some light here, and this goes to these caps over here on the other side. Yeah, and those return here. And that's really interesting. Yeah, so we have a cap here connected between those two lines. Okay, that goes to ground. So let's see. I'm curious of one thing. Let me power on the supply. The multimeter. Let's connect it and let's use connectivity. I'm curious if we have any short on that first cap here. Right, so let's go to the microscope plus, no, let's go to desktop plus microscope. Good. So I'm curious if here on the first cap we have any kind of a short. I hope we don't. Yeah, so now we have like 1 kilo, like 0.6 kilohms. Yeah, 0.4. Let's connect diode. Let's put it in diode mode, and I want to see again here on this cap. This is quite low. Yeah, we have a good reading on this side, but this side here is low. So it's this side here. So this seems to be like shorted to ground, and this is the area where the chip is lighting up. So what I'm gonna do is I'm gonna actually remove the chip. So for removing the chip, I'm gonna place the board on a heating plate, but usually the board stays like this, but I need to have access to this chip, so I'm gonna use a straight plate. I'm not gonna use the plate for 16, but I'm gonna take from here I'm gonna take this plate here, which is a straight one. I'm gonna place the board on the hot plate. Let me see how can I position it. So I need access to the chip. So I think we're gonna do it like this. Maybe put it on this side, and I'm gonna use this to somehow hold it in place. Let me see, like this. Okay, because I need access to remove that chip. Removing it's a bit complicated because there's a lot of parts on this side, so they are very close, and my hands are a bit shaky. It's gonna be a bit tricky to remove it. I think I'm gonna grab it from here, but I'm gonna put a hot plate, and I'm gonna have the plate heat up to 150 degrees, and then I'm gonna come with hot air from above. I think I'm gonna fast forward what's next, so it's gonna take a while, but I don't wanna cut it, and we'll see the result after. Okay, so we replace the chip. I have here a crooked cap, but it's okay. It's making contact. Now the line that we measured, and it was really low. Let's try to do this view here. Okay, so that line that is selected there, I'm gonna measure it on that cap, so red probe on ground. And let's see what value we had, 0.0 something, right? And now we have 0.3. 0.3, yeah, 0.203. This multimeter is very fast, and the other side we have 0.5. Yeah, so 0.3. I'm not holding the probe correctly. Yeah, so we are good. Let's connect the supply, and if we connect the supply here, so supply is connected. Let me move back to microscope and DMM. Power supply is connected. I'm powering on the supply. See, 4.1 and no power consumption at all, and that's good. And if we prompt to boot, we can do it from this pin here. connect it to a ground. Yeah, we can see a normal boot behavior. Now I'm gonna stop the supply. I'm gonna put the board back in the housing, and we're gonna check and see how the charging looks like. Okay, so I've assembled the phone. Well, assembled. I put the display back and the board, and without the front camera and the speaker, just the phone. I connected the battery. So I'm curious what happens now if we connect the USB, so we can see up on the screen the USB supply there. Yeah, I'm connecting it. See, there's also already a difference. The phone is starting. It negotiated the voltage to 15, and the phone is charging just fine now. Yeah, so that was it. I hope it was an interesting video. I'm sorry I didn't make videos in English lately, but I was a bit busy with the Romanian channel. I hope you enjoyed it. I hope you learned something, and if you liked it, give me a like, subscribe if you haven't already, and see you next time. Bye.